Hi friends, welcome to Devrat Knowledge Villa. You are watching our English video series and learning CPU scheduling. Today's our topic is priority scheduling. And in terms of priority scheduling, we will learn priority scheduling in preemptive mode. As per our earlier discussion, priority scheduling is working on basically both the modes, preemptive mode as well as non-preemptive mode. In case of preemptive mode, we can stop the process in between the execution of process and we can allocate CPU to the other process. Whereas in non-preemptive mode, we can't stop any process in between the execution and we can't allocate CPU to another process before the completion of first process execution. So if you are till remain to watch the non-preemptive mode priority scheduling, so please click on I button upper right corner and watch the priority scheduling and non-preemptive mode and come here again to understand the preemptive mode. Let's start how preemptive mode priority scheduling is working. It will follow the criteria of priority, and if priorities remain same, so as per non-preemptive mode we will look also for the arrival time. Let's take one example. Three processes P1, P2, P3, arrival time of all these three processes and priority. Right now see here, in place of burst time, one thing is given, that is timing used for CPU, then after timing used for the IO, and then after timing used for the CPU again. So nothing else, it's also a burst time. Whenever any process is using a CPU, so that time is known as a burst time. So see here, right now P1 is using CPU for 2 time units here and again 6 time units. So 6 plus 2 will be the burst time of process P1, and for the P2, first 6 time units and then again 2 time units. So 6 plus 2 again 8 time units is a burst time for process P3, and for the process P2, and for the process P3, 4 plus 2 is equal to 6 time unit is a burst time for process P3. We will calculate average turnaround time and average waiting time. But before start discussion, we have to decide the priority. So priority is given here 2, 3 and 1. So we have to decide lower number has a higher priority or a higher number has a priority. In our earlier video non-preemptive mode, we have taken higher number has a higher priority. Let's discuss this example with the lower number has a higher priority. So we are considering lower number has a higher priority. So higher priority is with the process P3, then after process P1, and then after process P2. So here P3 is a most important process, and then after P1, and then after P2. Let start calculating turnaround time and average waiting time. Let's see here, it is our data table given us as a data, and it is our Gantt chart. Here I am dividing entire Gantt chart into the different slots of 2 time units. As per the data given into the example, it is feasible. If you want to divide your Gantt chart into the time units of single time unit, so you can also divide it by the 1 time unit. Let's start drawing Gantt chart from time unit 0. So we will start to draw Gantt chart from time unit 0, and we will check any process is arrived at time unit 0 or not. Yes, at a time unit 0 process P1 was arrived. Arrival time for process P1 is 0 time unit. So we will execute process P1 first, because right now no need to compare the priority, because if more than one process is available, then and then we will look for the priority, otherwise it is meaningless to compare the priority. Get it? So P1 will start its execution and P1 will run for the 2 time units, because first time P1 requires CPU for 2 time units. Get it? So P1 will start its execution and P1 will use the CPU for 2 time units, because P1's requirement is only for 2 time unit. Done. So at a time unit 2, P1 will complete its execution of first portion. P1 requires CPU 2 times. first it is required for 2 time unit, and then after again it will require CPU for 6 time units. So here P1 is completing its first portion. So we cannot consider time unit 2 is a completion time of P1. Get it? Because again P1 will require CPU for 6 time units. So whenever P1 will complete its entire execution, then and then we will able to note down the completion time of process P1. Get it? Now check at a time unit 2 any other process is arrived or not. So if we will look into the data table of arrival time, so no one process arrived at time unit 2. Get it? So no one process will get the CPU and CPU will remain idle. Get it? Because next process P2 is arriving at time unit 4. So up to the time unit 2 to time unit 4, CPU remain free or idle. No one will use the CPU. One another thing, at a time unit 2 P1 is going to use IO devices. So also we will note down when process P1 is arriving again and it will require the CPU. Get it? So till that moment we will put P1 for the IO devices. Done. So it will require IO 10 time units IO devices. So P1 will start using IO devices for the 10 number of time units. Here as per I have discussed, we are dividing this Gantt chart into the slots of 2 time units. If you want to divide it into the 1 time unit, so you can also divide, but right now lack of the space and feasibility with the data, I am dividing it with the 2 time units. Done. Right now we reached at a time unit 4. So we will check at a time unit 4 any other process arrived or not. Yes, process P2 is arrived. Get it? And one more process was arrived, that is P1, but right now P1 is using IO devices. So only P2 is placing a request for the CPU and P3 is not arrived till this moment. So no need to compare the priority of P2 with the P1 or P3. Definitely P2 will goes for the execution. Done. So P2 will use the CPU for the 6 time units, but we can't allot a CPU for entire 6 time units, because at a after the arrival of P3 we will check the priorities of P2 and P3. So we will allocate CPU to the process P2 only up to the time unit 6, because at a time unit 6 one more process is arriving, and that is process P3, and P3 has a lower number priority and we have taken lower number is a higher priority. So we have to stop process P2 in between the execution and we will allocate CPU to the process P3. It's called preemptive mode. We are going to stop the process P2 in between the execution after executing for the 2 time units, whereas actually P2 requires CPU for the 6 time units. So we are stopping P2 after the 2 time units and we are putting the P2 into the waiting state. Get it? So right now arrival time of process P3 was 6 time units. So P3 will get the CPU. Done. And P3 will execute. Get it? We are allotting CPU for the 2 time units first 8. So again P1 is reaching at a time unit 2 plus 10 equal to 12. So no need to wait for the P1. We will continuously allocate CPU to the process P3. Done. And P3 is require CPU for the 4 time units. So again we will allocate for the 2 time units, 2 plus 2 total 4, and at a time unit 10 P3 will complete its first portion of execution. Like here P1 was completed its first portion of execution of 2 time units and P1 goes to the IO devices. Same like here P3 is completing its first portion of using the CPU for 4 time units and P3 will go for the IO devices. Get it? And it will require IO devices for the 6 time units. So again P3 will reach at a 10 plus 6 up to the 16 time unit here. Get it? Till that moment CPU is free and we can allocate CPU to the other processes. Other process is P2. P2 is requiring CPU. Actually P2 is requiring CPU for the 6 time units, and we have allocated CPU to the P2 only for 2 time units. Get it? Right now P3 is using IO devices as well as P1 is using IO devices. So only process P2 is in the Gantt chart. So we can allocate CPU to the process P2 for more number of time units, 2 time units. Get it? So 10 plus 2, it will be 12. But right now at a time unit 12, we have to compare the priority of P2 and P1, because here P1 is completing its use of IO devices, and again P1 is reaching to use the CPU. Get it? So we will compare the priority of P1 and P2. Done. So P1 has a priority 2 and P2 has a priority 3, and lower number has a higher priority. So P1 has a higher priority. So we have to allocate CPU to the process P1 and we will stop process P2 in between the execution. So we are going to stop P2 from the execution and we will allocate CPU to the process P1. Again this thing is known as a preemptive mode. We can stop any process in between the execution. So right now P1 will execute again, and P1 is requiring CPU for the 6 time units. Done. So 12 to 14 and again 14 to 16. Done. Up to the time unit 16 P1 will execute 2 plus 2 for 4 time units, whereas actually P1 requires CPU for the 6 time units. But here at a time unit 16 we have to compare the priority of P1 and P3, because here P3 is completing its work of IO devices and P3 is again reaching to use the CPU. Get it? So we will compare the priority of P1 and P3. P1 has a priority number 2 and P3 has a priority number 1, and lower number has a higher priority. So definitely P3 has a higher priority. So we will stop P1 in between the execution and we will allocate CPU to the process P3. Done. So P3 will start its execution, and again second time P3 requires CPU for the 2 time units. So P3 will use a CPU for 16 to 18. So here P3 is completing its entire execution. In first time P3 requires CPU for the 4 time units, and P3 was used CPU from 6 to 8 and 8 to 10. Again P3 goes for the IO devices and P3 uses IO devices for the 6 time units. Again P3 arrived and uses the CPU for 2 time units. So P3 will completely executed here. So 18 will be the completion time for process P3. Done. Now up to the time unit 18 P3 is completely executed. Now 2 processes remain, that is P1 and P2. Both are waiting for the CPU. Get it? So which one will get the CPU? So we will compare the priority again. P1 has a priority number 2 and P2 has a priority number 3. So definitely lower number has a higher priority. So again P1 will get the CPU. Done. And first P1 was used the CPU for 2 time units here, then P1 goes for the IO devices 10 time units, and again P1 requires the CPU for 6 time units. We have allocated CPU from 12 to 14, 14 to 16, 4 time units. Again it will require for the 2 time units. So we are allocating CPU for 4 plus 2, 20 time units. Done. So total P1 completed 2 plus 2 plus 6 time unit uses of CPU. So now we can say that P1 completely executed. So 20 will become the completion time for process P1. Now P3 was completely executed at a time unit 18, and now P1 is completely executed at time unit 20. So only one process remain, and that is process P2. So definitely right now we will allocate processor to the process P2, and P2 require the CPU for time unit 6. Done. Because right now P1 using the CPU for its first portion. Here P2 is used the CPU for 2 time units. Here again P2 is used the CPU for 2 time units, and again P2 is using the CPU. Here 2 plus 2 4, and again 2 time units 20 plus 2 20, 2. So P2 will completely executed its first portion. Done. Right now P2 require the IO devices, and P2 require the IO devices for 6 time units. So at that time CPU remain idle. Get it? Because P2 is going to use the IO devices. So 2 plus 2 plus 2 up to the 6 time units CPU remain idle or free, because P2 is going to use the IO devices. Again P2 will arrive at time unit 28, and at a time unit 28 we will again allocate CPU to the process P2. P2 is require the CPU for 2 more time units, and we will allocate it from 28 to 30. So right now we can say that P2 completely executed, and 30 will become the completion time for process P2. Done. So here all this process completely executed, and they got the CPU for as well as 2 times CPU, and also got the IO devices. Done. So all the process P1, P2 and P3 is completely executed over here, and right now we can note down the turnaround time and waiting time after getting the help of completion time. So equation of the turnaround time is completion time minus arrival time. So completion time of process P1 is 20, and arrival time of process P1 was 0. So turnaround time for process P1 is equal to 20 minus 0 is equal to 20. For process P2 completion time is 30 and arrival time is 4. So 30 minus 4 is equal to 26, and for process P3 completion time is 18 and arrival time is 6. So 18 minus 6 will be the 12. Done. So these are the values of turnaround time. Now we will require waiting time. Turnaround time means total number of time spent by the processes, because into the turnaround time all this time is calculated where process is using the CPU, or process is using IO devices, or process is in waiting, process is not using any type of CPU and IO at that time, process was in waiting. So that's why we want to calculate waiting time. So all time included into the turnaround time. So we will note down the how much time process is using the CPU. So remaining time process would be into the waiting for using the CPU. Done. So we will use the equation turnaround time minus burst time. So we will get the waiting time. Done. So here burst time is equal to the summation of first time processes are using the CPU and second time processes are using the CPU. Done. So here 6 plus 2 8 is a burst time for process P1. So 20 minus 8, it would be the 12. It is a waiting time for process P1. Again for the process P2 turnaround time 26 and burst time is 6 plus 2 8. So 26 minus 8 is equal to 18. For the process P3 burst time is 4 plus 2 6 and turnaround time is 12. So 12 minus 6 is equal to 6. That is the waiting time for process P3. Now we will note down the response time. Response time means when process got the CPU first time, that time is known as a response time. So process P1 was arrived at 0 and got the CPU at a time unit 0. So 0 time unit will be the response time for process P1. Done. For the process P2, P2 was arrived at time unit 4 and P2 got the CPU at time unit 4. So 4 time unit will be the response time for process P2. And for the process P3, P3 was arrived at time unit 6 and P3 got the CPU at a time unit 6. So 6 becomes the response time for process P3. Get it? Now we will calculate average turnaround time and average waiting time. Let's start calculating. For finding the average turnaround time, we will make the summation of all these three values. Average turnaround time would be the 20 plus 26 plus 12 become 58, and we will divide 58 by the total number of processes. Total number of processes are 3 here. So we will make 58 divided by 3 and we will get 19.33 time unit. That is the average turnaround time for all these 3 processes. Done. Next we will find out average waiting time. So for finding the average waiting time, we will make summation of all these 3 values, 12 plus 18 plus 6. So it will become the 36 and we will divide 36 by total number of processes are 3. So 36 divided by 3. So we will get 12 time units. Done. So average turnaround time is 19.33 time units and average waiting time is 12 time units. If you are getting any unit of the time like microseconds or milliseconds, so you have to write here whatever the unit is there. So it was a priority scheduling in preemptive mode. Earlier video we have discussed the priority scheduling in non-preemptive mode. So here we are completing both the portions of priority scheduling as per as the non-preemptive mode and preemptive mode. Our next session for the CPU scheduling would be the round robin, and round robin is working into the preemptive mode. So thanks for watching Devrat Knowledge Villa, and allow me to leave for the round robin. Thanks once again.